Alrighty, single replacement reactions. What does it mean to replace something? Like if you have to replace a light bulb, it means that you need to exchange it. You need to switch it out. So in a single replacement reactions, atoms of an element are going to replace the atoms of another element in a compound. So I call this the affair. Ooh, this is so scandalous. All right, and you can have all different kinds of affairs, but what we're going to focus on here in chemistry is going to be when a metal is going to replace another metal, and when a nonmetal is going to replace another nonmetal. So remember, whenever we write our reactions and our compounds, okay, if you have a compound BC, B is always going to be the metal. Okay, we write the metal first, and we always write the nonmetal second. Everything in chemistry builds on itself. So we're like slowly building up all these little foundations as we go through. Okay, so when you have your metal replacing a metal, A is going to replace A. A is going to replace A. One third time. A is going to replace B, and B now becomes the single element. And then A takes its place bonded to C. But on the other hand, when you have a nonmetal replacing a nonmetal, A is negatively charged. So when you have your compound, it's going to go after C. C gets kicked out by itself, and then you have your positive, then your negative compound over here. Now be careful here. B, excuse me, B, careful. B comes first because it is always going to be the metal and then the nonmetal. So to help you with things in the traditional sense, we usually talk about the case of the other man or the case of the other woman. So metal replacing a metal, and I usually say that the metals act kind of like the men because they both have M's in them. All right, and we have A plus B yields AC. A plus BC yields AC plus B. All right, the metals can only replace other metals, and it's going to be shown as that first substance. It's the cation replacing the cation because the cation is going to bond to the anion. So what we have to do is we have to consult the activity series of metals to see if the reaction will take place. And the activity series of metals is a specific list where we basically rate like hot or not. So we have the most active to the least active. And I embedded a link right here inside our uh, presentation. Okay, so to show you that, this is what it looks like. All right, so for single replacement reactions, you have your two types of reactions on the left and on the right hand side. So this is going to be when A is trying to replace B and where A is going to try to replace C. So for your metals, you have your most active ones at the top and your least active ones down here at the bottom. Okay, and same thing for your nonmetals. You have the most active at the top and the least active at the bottom. And the way that this works is if you are more active, you are going to replace something underneath you. But if you're less active, you won't be able to replace what is above you. So if we go back to our examples here, it should start to make a lot of sense. Just because somebody is given the opportunity to cheat doesn't mean it's necessarily going to happen. It's only going to be when you have something more active trying to replace something underneath it. Then it happens. But if you already have something golden, you're not going to replace it for something magnesium. That's not going to happen. So you'll see that some of these reactions don't happen. They have to be more active. They have to be better. Okay, so if you take a look at this example, we have our magnesium and hydrogen. So Mg plus HCl. Mg makes a 2 plus, H makes a plus, Cl makes a minus. It's always good to map out your ions. Metal will replace metal. Cation will replace cation. Is magnesium stronger than hydrogen? Yes, it's higher on the list. Magnesium is up on the top, hydrogen is below it. So magnesium is stronger and can kick out hydrogen. So hydrogen goes bye-bye. Again, be mindful of diatomics. And then we get Mg2 plus and Cl minus to make MgCl2. And what happens is the magnesium is going to dissolve and it's going to make an aqueous and it's going to bubble up and make your hydrogen gas. This upward arrow means that a gas will be released. But if you have gold and hydrogen and chloride, gold is down here. The gold is not strong enough to replace hydrogen, so no reaction. You wouldn't want your golden ring, your symbol of forever, to get dissolved whenever you use any type of acid, whether that be a soda or lemon juice or anything that is slightly acidic. So you'll see that it's not always going to work. Okay? Iron will replace copper, but copper won't replace iron. Fe is higher than copper, so you'll see that Fe will kick out copper, and it looks like it rusts, but it doesn't, it's just the copper. And then Fe will bond with chlorine. But if you put a copper penny into an iron chloride solution, since copper is lower than iron, it's not going to work, and you literally write no reaction. The same thing happens for your non-metals, okay? The case of the other woman. When the negative non-metal is going to try to replace the other non-metal, okay, it has to be higher on the activity series. So again, anion replaces anion. The activity series is the same thing as group 17, your halogens on the periodic table. You have fluorine, then you have your chlorine, bromine, iodine, and then we have astatine. Notice how we never really talk about astatine? Because it doesn't do much. It just sits there. It's so unreactive. Okay, so again, group 17, your halogens, okay, go fluorine, chlorine, bromine, iodine, astatine. All right, so chlorine and NaBr, chloride will try to replace bromine. Chlorine is above bromine, so it'll happen. So then you kick out the bromine, mindful of diatomics, and then you get your Na plus and Cl minus, making NaCl. But iodine tries to replace bromine. You're not going to see that happen because it's lower. So there's just simply no reaction. So to review, identify when you see a substance that is one atom and one compound. Make sure you know the ions of each one. Is it the cation replacing the cation or anion replacing the anion? Don't let the diatomics throw you off. Make sure you check your activity series. It is the third most important piece of paper that you are going to get this year. The first being your bestie, your second being your activity series, and this is your third. And then you are going to see if it replaces, then make your neutral compound and your atoms and balance. Okay, so let's try these. All right, so we have Na plus H2O. Ions, ions, ions. They're never going away. Na makes a plus, H makes a plus, O makes a 2 minus. So Na is going to try to replace H. Is Na higher than H? The answer is yes. So kick hydrogen out. All right, hydrogen's diatomic. And then what you're going to do is you're going to have Na plus and O2 minus, making and actually you're going to have hydroxide here. My bad, my bad. OH minus, you're going to have NaOH right here. All right, H plus and OH minus is what it will be left, and you'll have your NaOH. And this is actually how you can get some Drano. NaOH is going to be your Drano. And then when you balance this out, you put a 2 in front of the Na, a 2 in front of the H2O, and a 2 in front of the NaOH. And it looks like so. All right, iron plus copper chloride. All right, iron makes a 2 plus or a 3 plus. I think we have a 2 plus here. I should have probably put that in there. I'll fix that afterwards. And we have our Fe2 plus and our Cu plus and our Cl minus. So iron is going to try to replace copper. Is iron higher on the activity series? Yes. So kick out copper. See you later, copper. And then you have Fe2 plus and Cl minus. So that is going to make FeCl2. And that is nicely balanced already. All right, what about silver and zinc oxide? Element compound. Ag plus, Zn2 plus, O2 minus. Silver is going to try to replace zinc. Is silver higher than zinc on the series? No? Okay. So all you got to do is write no reaction. That's it. That's done. Okay, next. Iodine and KCl. I makes a minus, K makes a plus, Cl makes a minus. So I is going to try to replace chlorine. Is I higher than chloride? No? No reaction. Okay, we're on a roll here. What about fluorine and KCl? F makes a minus, K makes a plus, Cl makes a minus. F is going to try to replace chloride. Is it higher? Yes. Okay, so kick out your chlorine, mindful that it's diatomic, and then you get K plus and F minus. So you get KF, so that you are successful. And then we balance it out by putting a 2 here and a 2 here. All right, and then we are balanced. Okay, so if you can't read my writing, here you go. Here are all of our answers for you. Oh, here I had it as a 3 plus, so sorry about that. Okay, so here it is, Fe, and then you have your 3 plus and your Cl minus, make it FeCl3, and then balance accordingly. All right, and you guys know how to do that. So this is successful because it's higher. Your Na is stronger than your hydrogen. Fe is higher than copper, so that's successful. Silver is not more active than zinc, so no reaction. Iodine is not higher than chloride, no reaction. Fluoride is higher than chloride, so it's successful. And that is your single replacement reactions, or otherwise known as the cheat.